My name is Sandeep Shah. I am the Manufacturing and Assembly Subsystem Manager in the Upper Stage Project Office for the Common Bulkhead on the Ares 1 rocket. At the beginning of the Upper Stage project, the design for the upper stage were separate tanks separated by an intertank. But that architecture was about 1,400 pounds heavier, and because of the payload weight requirement, we had to shave off 1,400 pounds from the structure. One solution to that was use of a common bulkhead by eliminating the intertank and the two domes on the hydrogen tank and the oxygen tank. Common bulkhead historically was used in the Saturn vehicles for the same reason, which is to save weight. Once the decision for common bulkhead was made to be used in the upper stage for Ares 1, the challenge we had was material obsolescence, where some of the materials used in the Saturn days were no longer available, and to establish the manufacturing processes and reinvent the manufacturing processes. But at the same time, make improvements so that the challenges that they had in Saturn common bulkhead manufacturing were alleviated for manufacturing the common bulkhead on upper stage. The risk was that as we design the common bulkhead and make the prototype at the same time, that the manufacturing would influence design changes which would not be ready for production, resulting in cost and schedule impact. Because the common bulkhead structure is the first item on the critical path for upper stage manufacturing, we had to baseline the manufacturing processes and select the materials way ahead of its need on the upper stage. Behind me, you see the prototype manufacturing demonstration article for the common bulkhead. It's 18 foot in diameter with a sandwich structure. What you see here is a cross-section of the common bulkhead, a typical cross-section. It consists of two metal surfaces that are bonded to a phenolic honeycomb structure, about 2 inches thick. The green over here is the adhesive, which is used for bonding the aluminum surface to the honeycomb structure. The honeycomb structure is what gives the structural strength to the common bulkhead. On the upper side of the common bulkhead, we have liquid hydrogen, and on the underside of the common bulkhead, we have liquid oxygen and hot gas during flight. And that gives a temperature difference of about 540 degrees Fahrenheit between the two surfaces. One of the focus in manufacturing we have at Marshall Space Flight Center is to do a full-scale demonstration of the technology that we want to implement in production. That's the only way to learn what's critical, what's not, and to really transfer the production processes to a production floor. The common bulkhead, some of the steps that we had to follow was first select the materials, establish some processes for those materials, go exercise them in the laboratory at various scales before we went to a full-scale article, generate specifications if those processes worked that could be used for production, make a test article like you see behind me, and also test the test article by non-destructive inspection or a cryogenic proof testing to certify the processes, and then transfer it to production for implementation. As we go through the manufacturing process, at every step we collect another data. That data is the amount of time it took us to execute that manufacturing process. At the end of the prototype manufacturing phase, we estimate for production purposes how much time it would take us to manufacture the article. As an example, for the common bulkhead, we estimated that it would take us 96 days from cradle to grave, which is proof testing for the common bulkhead article, just because of the sheer complexity of the manufacturing processes. We hope by the 5th or the 10th article that we would manufacture for flight, there would be lessons learned, and we would have shortened the number of days for manufacturing. In the manufacturing process, at every step, we had quality involved, working together with us, and to identify key process characteristics that they would like to follow and track during the production process for the quality assurance that we would have on a flight article. When we established the risk for common bulkhead manufacturing, it had multiple components, basically unknowns in the risk, that we had to establish mitigation plans for each unknown. As an example, spin forming of a common bulkhead dome was not done at this diameter. The adhesive bonding and adhesive selection was not done. So when we were reviewing the risks, it used to be a very complex mitigation strategy. One of the risk mitigation strategies we used was to break the mitigation steps into children risks and track individual children risks to their completion. Of course, the entire risk was closed when the prototype article was made and all the processes were established. But we could, in the interim, close children risks and better assess our progress in closing the overall common bulkhead risk. Having established a top-level mitigation strategy, as we dove deeper into each one of those mitigation steps, there were several things we learned, some things that worked and some things that didn't work. One of our challenges in establishing the manufacturing process for common bulkhead was to meet the schedule for CDR. We had approximately about 2 years to establish all the manufacturing processes, specifications, and proof test, certify the common bulkhead structure to be ready for critical design review so that it can be used in production, flight production. The challenge was this was a very aggressive schedule because a development effort could lead us in any direction, whether we have success or failure. We had to react very fast to failures, and we had to move fast away from successes to meet the aggressive schedule. At the same time, we were limited by budget, so we had to be creative in trying to reduce the number of steps and to maintain within the budget we were given. So once the decision to have a common bulkhead on the upper stage was made, we went back to the historical databases available for the Saturn. And in our research, we went to the Marshall Technical Library and found reports which documented the manufacturing processes, some of the materials selected, as well as the challenges that they had during that day for manufacturing a 33-foot diameter common bulkhead. We also went to the Space and Rocket Science Museum out here, where we have a Saturn on display, and we looked at the common bulkhead article that they had in the Saturn vehicle on display. A third part was also to have graybeards from who had worked on the common bulkhead in the 1960s involved in our daily tag up and meetings and educating us about their lessons learned in manufacturing common bulkhead in the 1960s. One of the lessons learned that I learned in managing this project that I would like to pass on to anybody who wants to establish manufacturing processes is try to establish them on full-scale articles. That's a key lesson learned because there are a lot of things that you learn on a full-scale level that you do not learn at the laboratory level. The other lesson learned is to establish margin in a development schedule, because you never know when things can go wrong in a development process, and the margin can help you deliver the product on time. We have been successful in manufacturing a prototype common bulkhead article, which I believe is extensible to other vehicles. So if you really want to know anything about common bulkhead manufacturing, feel free to contact me or the Materials and Processes Laboratory at Marshall Space Flight Center.